Okay, let's dive in. So, think about maps, old maps maybe, trying to chart the unknown, putting, here be dragons on the edge.
Yeah.
Well, today we're talking about mapping something, well, much, much further. The absolute deepest parts of the universe.
Hmm.
We're looking at Cosmos Web. It's this huge new map made possible by the James Webb Space Telescope, JWST.
Exactly. And our mission today really is to unpack what this map is, why it's such a, well, a monumental thing for astronomy,
Right.
what it's telling us about the very early universe, and also these kind of surprising puzzles it's throwing up.
Puzzles are good.
They are. And we're drawing this from the sources you shared, especially that great Science Alert piece by Michelle Starr. The universe's largest map has arrived. You know the one.
I do. It's pretty amazing just thinking about JWST sort of staring fixed
It's right.
at this tiny seeming patch of sky.
Unblinking,
I
yeah.
saw that first image drop maybe a month ago. That was just a glimpse.
Right, the teaser.
But now the whole thing is out. The interactive map, all the data, it's all been released. For scientists, yes, but really for anyone.
And the scale is what's just mind-blowing here.
Yeah.
You know, we talk about deep fields. Hubble's ultra-deep field, maybe 10,000 galaxies. Famous picture.
A classic.
Well, Cosmos Webb, it has nearly 800,000 galaxies in its feet.
800,000.
Yeah, that's not just a small step up. It's a massive leap.
That's hard to picture. I read Caitlin Casey. She co-leads the Cosmos project. She had this great analogy.
Oh, yeah?
She said, imagine the Hubble Ultra Deep Field is printed on like a standard sheet of paper.
Okay.
Then the Cosmos Webb image, same depth, would be like a mural, slightly bigger than 13 feet by 13 feet.
Wow. Okay, that really helps. That's enormous.
It really is. So much data.
And just to give another sense of it, the area of sky it covers, it's about the size of 7.5 full moons put together.
7.5 moons, so it's not just deep, it's wide too.
Incredibly wide, yeah. Giving us this amazing panoramic view way back in time.
And looking back in time, that's the whole point of JWST, isn't it? Peering into what they call the cosmic dawn.
Exactly. That's its primary mission, really. Understanding that first billion years or so after the Big Bang, 13.8 billion years ago, roughly.
When the first stars and galaxies were just switching on.
Precisely. And it's incredibly hard to see that stuff. It's obviously extremely far away, so the light is incredibly faint.
Right.
And because the universe is expanding, all that light gets stretched out, redshifted, way into the infrared.
Which is exactly what JWST is designed to see, that infrared light.
That's the key. Its power, its resolution, its infrared sensitivity.
Yeah.
It's built specifically to find that incredibly faint, redshifted light from the dawn of time.
Like the perfect tool finally arriving. And Cosmos Webb is really pushing that tool.
Absolutely. It's looking back as far as 13.5 billion years, so right into that crucial era when the universe was just starting to clear up.
Clearing up from what?
Well, this kind of opaque primordial fog that filled everything in the very beginning. That fog was lifting, allowing light to travel.
Okay.
And the researchers, they're not just hunting for individual galaxies, They want to see the whole system.
How they fit together.
Yeah, a cosmic ecosystem. This interactive gravitational dance between objects, all held together by that invisible cosmic web of dark matter.
That dark matter scaffolding.
Right.
Right. So Hubble, you said, barely scratched the surface. What's the big reveal from JWST then? What's surprising?
Okay, so here's the big surprise, as the article calls it. Astronomers are seeing, well, about 10 times more galaxies than they expected to see that far back.
10 times more.
10 times. And not just galaxies, they're spotting supermassive black holes, too. Things Hubble just couldn't pick out at all.
Wait, 10 times more galaxies than expected. How does that even work? Don't our models predict how galaxies form over time?
Exactly. That's the whopping great puzzle, as Casey puts it. According to our current understanding, our models of galaxy evolution, there just shouldn't have been enough time since the Big Bang for so many well-formed galaxies to exist already.
So finding even one is odd.
Finding even one is a bit of a head-scratcher, yeah. But finding them in these numbers, it really kind of boggles the mind.
So our models might be wrong, or at least incomplete.
It strongly suggests that, yes, our foundational ideas about how quickly structure could form, how much time things need to grow and gather mass,
Yeah.
maybe they need rethinking. You start asking questions like, was dark matter behaving differently back then? Or maybe star formation was just way, way more efficient than we thought possible.
That's a fundamental challenge.
Wow.
Wow, okay, so huge scientific implications. But you mentioned something else about how this project works.
Yes, and this is really important too. The whole approach is about democratizing the science.
Meaning?
Meaning all this data, the images, the catalogs, it's not locked away. It's free.
Yeah.
It's available online for anyone, any scientist, any student, any curious person. You can download it and work with it.
Anyone can take a shot at solving these puzzles.
Exactly. It's collaborative.
I like that quote from Caitlin Casey again. The best science is really done when everyone thinks about the same data set differently. It's not just for one team.
Precisely. Let different minds bring different perspectives. That's how you make breakthroughs.
So people are already digging in.
Oh, yeah. Papers are already being submitted to the big journals, like the Astrophysical Journal, Astronomy and Astrophysics. That's happening.
Okay.
But maybe even more exciting for you listening, you can actually go to the Cosmos Web Interactive website right now.
And do what?
And just explore. You can zoom through this incredible image of the universe almost all the way back to the beginning of time. You can just, as the article says, muck about in the data.
That's pretty cool. So just to recap, we've gone from ancient maps to this absolutely monumental map of the early cosmos web.
Yeah, staggering scale.
Revealing maybe 10 times more galaxies than we thought should be there, posing this huge puzzle about how galaxies form so quickly.
Real challenge to our models.
Yeah, and all this data is open for everyone to explore, maybe help figure it out.
Absolutely. That spirit of shared discovery is key, and the fact that you, listening now, can interact with this potentially universe-changing data, it's quite something.
It really is. So maybe the thought to leave everyone with is, if our current ideas about galaxy formation are being stretched, maybe even broken, by these early galaxies, what else might we be wrong about? What fundamental ideas about the early universe might need a rethink? And, what amazing new possibilities could that open up for understanding where it all came from, our cosmic origins? Okay.